Hi, my name's Dr. Carol Hood, and I'll be your instructor for this astronomy lab class. I'm going to take a moment to talk about what we're going to do in this lab class, tell you a little bit about myself, and then finish with some to-do items for this first period. So this astronomy lab assumes that you are either already currently enrolled in an astronomy lecture class or you've already taken one. So the hope is that you'll see some of these concepts in lecture, and then we'll be able to apply them in a hands-on manner in lab. So some topics that we'll touch base on are telescopes, some properties about telescopes. This image is actually showing one of the astronauts removing and letting go one of the solar panels on the Hubble Space Telescope. The blue that you can see there is the Earth that's down below. It just happens to be one of my favorite images. So we'll learn about how telescopes work, since they are the primary tool that astronomers use to learn and discover things about the universe. We'll talk about the stars, what kinds of different stars there are, what we can learn from them. We'll talk about galaxies. Here's an example of a spiral galaxy. We'll talk about the different types of galaxies. We'll talk about their motion and what that can tell us about things. We might touch a little bit on dark matter, which is also housed in galaxies and outside and around galaxies. We'll talk about cosmology, which is the study of the universe as a whole. Each of these little dots in this image is a galaxy. There are billions upon billions of galaxies out there. So we'll look at some hands-on images and data to learn what we can about the universe and to get an idea of how astronomers actually go through and do this when they're doing their own research. We'll learn about the moon phases, also called the lunar phases. And we'll end the class talking about exoplanets. So this is one of the first images of exoplanets ever created. The planet is not the blue thing in the middle of this red ring. That's actually where the star that the planet is orbiting is. The planet is actually embedded inside that red ring as a little tiny red dot. So in that zoomed in figure, you can see that little dot moved a tiny amount compared to its entire orbit over the course of 2 years. So this is one of the very first actual images of a planet orbiting around another star. And hopefully you'll learn more about some of these exciting discoveries in your lecture class. We will focus on the mechanics and how astronomers actually were able to do all of this. So I always like to start my classes with a little bit about myself, and I'll ask you to do some of the same in a video yourself that you'll make in a little bit. So I grew up in Houston, just nearby the Johnson Space Center, which is where all the astronauts live. So that's the picture in the upper left-hand corner. So the Johnson Space Center is shown there. One of the space shuttles after its retirement was flown over the Johnson Space Center. I'm still a little bitter that the Johnson Space Center did not get one of the space shuttles themselves, since that's where the astronauts actually all lived, was in and around this area. And my home was somewhere past that bayou in the upper right-hand corner of this picture. Looks like you might even be able to see a little bit of a neighborhood back there. That's roughly where my house was. So I spent my childhood there up through middle school. When I was in 8th grade, my parents pulled myself and my sisters aside and said we were going to go on a big vacation. This was the biggest vacation that we'd ever done before. Get on a plane, giant trip type thing. Normally it would just be go to grandma's house or something like that. They said we were going to go to Hawaii, which got us all very excited. And then immediately after that, they said we were moving. So I called that the pity trip from that point on, since they sort of baited and switched us with an amazing trip to Hawaii, which we did get to take, and then leaving all of my friends that I had ever known and moved to Virginia. So my parents worked at the University of Virginia, which is in Charlottesville. That's the picture on the lower left-hand side. The big round white-roofed building is known as the Rotunda. So the University of Virginia was founded and actually architecturally designed by Thomas Jefferson, the third president of our country. His home, Monticello, is not too far away from there. So the University of Virginia is where my parents worked So I went to high school outside in the county, in that area, much more rural than I was used to. I was used to suburbia. So I went to high school there, and then when it was time for me to go to college, I decided to go to the other large university in the state of Virginia, which is Virginia Tech. So you can see the logo there. I'm big into college football, if and when we're ever able to do it again. I'm a big Hokie fan. That's our mascot. And I went to Virginia Tech as a physics major. So out of all of the sciences, physics is the one that spoke to me the most. Biology seemed like it had too much memorization. Chemistry had all these rules, which I was okay with rules, but then you had to memorize all the ones that broke the rules, which seemed counterintuitive to me. So for me personally, physics was really logical. And I was very much interested in space and how all of this applied into space. So I already kind of had a hint that astronomy was something I wanted to go into. So after I graduated with my bachelor's degree in physics from Virginia Tech, I went to graduate school. So I went to get my doctorate, my PhD, and I applied to essentially all the UC's, University of California schools, because I knew they had access to the two largest optical telescopes at the time, which are the Keck telescopes, which coincidentally are on the Big Island in Hawaii. So I went to UC Irvine, which at the time had a small department but has grown by leaps and bounds in the years since. I actually have a lot of students that are attending there now and earning their own PhDs. And UC Irvine, despite moving across the country and taking my little dogs with me, is where I met my husband. You can see in a very old picture prior to children in the upper right-hand corner with our two dogs, Nikki and Molly. So Molly had to be put down almost this time last year. She was 17 and a half years old. Nikki is still with us. She'll be 18 in December. So I am evidently very good at keeping dogs alive. Plants are another story. And so far I'm doing pretty well with my kids, so fingers crossed there. We have two sons, Elliot and Andrew. Elliot's the older one. Andrew's the younger one with long hair there. Elliot will be going into 4th grade this fall, and Andrew will be going into 1st grade this fall. So this is roughly my path to how I got to where I am today. So after I graduated with my PhD from UC Irvine, actually while I was a student there, I started teaching at Mount SAC, as well as Santa Ana College down in Orange County. After I graduated, I took a job at Augusta State University in Georgia for a year. Elliot and I actually moved out there ourselves while Mike stayed here because he was already working full-time at Mount SAC. And then I eventually, after a year, took a job at Cal State San Bernardino, which is where I've been ever since. So I've been teaching for well over a decade and on and off at Mount SAC over that time period, so I'm quite familiar with Mount SAC itself. I love my job. I love teaching students. I love getting to know my students. I love seeing my students succeed. It's a big part of why I do what I do. So if anyone has any questions, feel free to ask, especially as they pertain to transferring, if that's something you're interested in, or just going into science in general. I do a lot of work with faculty colleagues at Cal Poly as well. So if that's a place you're interested in transferring in, I can probably assist there as well. Although I will say San Bernardino has smaller classes and you'll get to know people a lot better there. So just saying. Anyway, so in this class, we're going to go through and look at how to do science. So this is a lab class. It's about doing, not just about memorizing a bunch of facts. So I actually do a lot of work on my home campus of Cal State San Bernardino, helping faculty learn how to teach because, surprise, surprise, we actually never took classes on this in school. Science teachers don't. In fact, most people, unless you're in education itself, you don't ever learn how to teach. So this is something that I have been learning for quite a while and that I am helping my faculty learn as well. So some of the ways we can organize knowledge and how well people understand that knowledge is through something like what I'm showing here. This is known as Webb's depth of knowledge. So Webb was the one that came up with this specific sort of organizational strategy. So in the depth of knowledge system, the lowest level is basic recall. So can you remember and memorize facts, terms, properties? Can you follow a set procedure or steps? You may not know the answer. It's much more about repetition and recall and identification. So the next level above that, because often you have to be able to know various terms and things like that in order to move forward. The next level, the skills and concept level, is when you start to engage with the material beyond just remembering what these words mean. So you're starting to make decisions on how to approach and solve problems yourself. You're starting to classify and organize the data, so you have to have some understanding of that data before you can classify and organize it. The third level is strategic thinking. So now you have to start reasoning with whatever it is you're working with. So this is a much higher order thinking than levels 1 or 2. Often requires multi-step tasks. You have to draw conclusions from the data. The highest level is the extended thinking. So you understand a topic so well that you can do open-ended tasks that require very complex thought. You might be able to design your entire experiment from beginning to end. You can make connections outside of what you may have originally thought of. So this is sort of the expert level for any particular task. And when I say expert, I don't necessarily mean like you are the world expert in that one particular thing. But you've gotten yourself from the novice level 1 who's never heard of this to a really good, complex understanding of whatever that particular topic is. My goal in this class is to get you somewhere in the levels 2 or 3 range for most of the topics that we're going to be encountering. So there'll be some initial level 1 type stuff, but we're really going to be engaging with the data, the measurements, the knowledge to understand what's going on at a deeper level. So I like to talk about this a little bit so that students can get an idea of where I'm coming from. Now, lastly, I want to go through and talk about a few of the items you'll need to do in order to get started in this class. So as you go through and look at the rest of the pages in Canvas for this particular Lab 1 module, there'll be a number of items you'll need to go through and do. One is you'll need to make sure you sign up and activate your account for Slack. So Slack is a communication tool similar to text messaging, like a WhatsApp type thing. It can be used as an app on your phone, which is how I primarily use it. You can also, there's a desktop application, as well as you can just use it within a web browser if that's what you want. But that's going to be our primary means of communication. So if you're working on an assignment and you have a question, put your question into Slack. Maybe other students will answer if I don't get to it in time, or I'll answer it. You will get the fastest response from me if you ask a question in Slack. So there's the main channel that everyone can see. So if you're trying to work on things together, you can put things in there. If you have a specific question for me, you can direct message me. But in most cases, I'd rather that go to the channel, because if you have a question, so does everyone else. So if you happen to direct message me, I might just post that question into the channel and answer it there so that everyone else can see the same answer. That way I don't have to keep answering the same question over and over. But again, feel free to direct message me, that's okay too. And all of that can be done within Slack. You can also create your own channels for your own study groups if you find that useful. I've had students do that a lot in the past. So it's a really great communication tool, and it'll be much faster than, say, the discussion sections and things like that. You can also set it to turn off notifications or turn on notifications if you want to see every single message that comes in. You can set your Slack notifications that way. You can also pause or snooze them if you don't want to be disturbed for a particular period of time. And then you can turn it back on when you're ready to see what those happen to be. Completely up to you. This lab class, especially because it's online, is going to utilize a lot of the Google applications, particularly Google Sheets and some of the add-ons. These add-ons can only be used on a laptop or desktop. They do not work in the tablet forms of Google Sheets, in the Google Sheets app. It has to be used in the web browser. And And some of our labs will require simulations that are based in Flash. Now, Flash is supposed to be ending at the end of this year, but we can still use it now. There are instructions in these Canvas pages for how to either install Flash if you don't currently have Flash installed, or how to enable Flash in your web browser. Because for most of you, it's probably installed on your computer, but your web browser may be blocking it, again, because most sites are starting to get away from this. Unfortunately, the astronomical community is a bit far behind, and I really don't want to think about what's going to happen come January. But that's not your problem, so we'll get to that. We'll cross that bridge when we get to it. So because we will be needing to utilize either desktops or laptops for many of our labs, if you don't have one, you'll want to fill out the form to get a loaner for Mount SAC as soon as possible, as in today. You're listening, watching this message right now at this moment. You want to go ahead and do that right at this very moment. They might run out, and I don't want you to miss out because of that. They're also offering internet hotspots, so if internet is an issue at your home, wherever you're living right now, you can request to get a hotspot as well. Whether that's because of financial issues or whatever it happens to be, fill out that form to try and get one. I'll have a Google survey for you to fill out, again, as one of these initial items, which will ask you some of these technology access questions so that at least I know what's going on. It'll ask some math and science background information, some get-to-know-you questions. It's also going to ask you for your phone number. And that's because since everything that's gone down since March, a lot of students have sort of disappeared off of our online radar for significant periods of time or entirely. I know there's a lot of reasons for why that is. And so if I notice that you have missed a couple of deadlines, I'll email you to check to make sure everything's okay. If I haven't already heard from you, email me back and just let me know that you're around and you're aware you've missed those deadlines. There will not be any late penalties for turning things in late. So this is really just a touch base. Is everything okay? If I don't hear back from you, I'm asking for this phone number so I can contact you to make sure everything is okay, both for my own peace of mind, as well as for Mount SAC, and as well as for you as well. I think we as a community need to do a better job of staying socially connected right now, so this is part of my way to do so. So of course you don't have to put that in there, but I certainly hope that you do. I also hope that I don't have to use it. If you're terrified of me calling you, then just make sure you stay in communication. That's really all I'm asking for. If for whatever reason things are running behind and you're not going to make a deadline, send me a message either on Slack or through Canvas and just let me know, and then I won't bother you because I know that you're still with me, you're still engaged, even if you need a little bit more time. That's totally fine. The other assignments that'll be due for this particular lab, and in general there will be somewhere between 2 to 3 labs per week depending on holidays and whatnot. Some of those labs may be multi-parts, like this first lab includes multiple parts, but on average you should estimate about 8 hours of lab work a week, since this is a short session, so make sure you plan your time accordingly. And there's some tips and tricks in there in these Canvas pages on how to go through and do that. So I'll ask you to make an intro video somewhat like this, although much shorter, hopefully. You won't need to give nearly as much information as I am trying to give you. And there's some prompts and parameters for that video to be shared out with the class. There'll be another short survey based on the concepts of latitude and longitude so that we can start talking about data and what that means. So fill out that survey. You get to Google a couple of things. It should not take you more than 5 or 10 minutes to complete that. And then there's a math review, and there'll be an additional video like this to walk you through that math review in case it's been a little while since you've used things like unit conversions or standard scientific notation. Excuse me. There'll be a checklist at the end of every lab so you can make sure that you've gotten everything done. In the grade book, grades won't show up as numbers, they'll show up as check marks for complete or X's for not complete. And I'm going to be using the Learning Mastery system. So if you go into your grades and click Learning Mastery, there'll be more information. Your goal is to get either a meets expectations or an exceeds expectations for any of your lab assignments. And there's more information about this in the Canvas pages for you to click through after this. And again, feel free to ask me any questions as they come up. I'm happy to clarify anything. So welcome to Astronomy 5L for this summer, and I'll talk to you later. Oh, and one other thing, since I forgot. I am not the only Dr. Hood in the Department of Earth Science and Astronomy. I mentioned earlier that I work here part-time. My husband, shown in one of the earlier pictures, Mike Hood, is one of the department chairs for the Earth Science and Astronomy department. There are actually two department chairs. They work together. Julie Breali is the other one. So if at any point you have concerns about me or my teaching and want to bring that up, I want to make sure you know what the sort of chain of command is. I would imagine if you had concerns about me, you would not feel comfortable taking them to my husband. So you should take them to Julie Breali, is the co-department chair. She can handle any issues related to me or my class. I hope, of course, there aren't any. But if there are, I want to make sure that everyone feels comfortable expressing those concerns. So she would be the appropriate person to go to. And if you don't feel comfortable going to her, you can always go to the Division of Natural Science office as well. But generally, department chair is sort of the next step up from a faculty member if there are any concerns. So you should be able to find her contact information on the Mountain Psych website if there are any issues. So I will be posting other labs as they finish, generally a week in advance, but eventually I'll get them all up. So if anyone wants to work ahead, they are more than welcome to. Again, there will not be any late penalties for turning anything late, but there are due dates. Things are due generally Monday, Wednesday, or Friday to get some schedule and regularity in there for you. In my experience, people that are able to meet those due dates are the ones who are able to pass the class in the end. So it's definitely something to strive for, but know that I know that the world is a little wild right now, so there is a lot more flexibility during this session than I might normally have for a class. So welcome again, and I look forward to getting to know you all.